When you're troubleshooting a chromatographic problem, there are often many different ways to find the potential cause of the problem.
Darren is a GC application specialist and tends to focus on the columns and supply. I'm a service engineer. I'm called out to troubleshoot and repair instruments. Most of the time, the instrument really isn't the cause of the problem.
In this segment, we're going to talk about the causes of retention time shifts. And here's an example of an issue that could come from a wide range of problems. Here's what we're talking about with retention time shifts. Now, what could cause this? Well, if your issue has occurred after installing a new column, then most likely a shift in retention time is due to dimensional differences in the old and new columns. The previous column was likely trimmed during inlet maintenance, and so the new column is likely longer than the old one. Also, there's column-to-column variation due to dimensional tolerances. There's a range for diameter and length. The diameter of a column can vary by plus or minus 6 micron compared to the nominal diameter. The length can be up to 1 meter longer than the nominal length, so that if you have a 30-meter column, it's guaranteed that it's at least 30 meters, but it could be as long as 31 meters. For a given pressure, you get a given flow. If you set the same pressure and the dimensions are different, you'll get the wrong flow.
Wow, that small difference can cause a problem like this?
Well, usually the differences are too small to cause too much of a problem, but sometimes if the columns are old and new again, and they happen to be at opposite extremes, the difference can be large enough to cause an issue.
But a lot of new GCs have electronic pressure control, so most people just type in the desired flow into the instrument control software.
That's right, but we need to remember that the EPC doesn't measure flow. It calculates the pressure needed for that flow, and it does it based on the information you give it, including the dimensions of the column and the type of gas. If you give it the wrong dimensions, you get a wrong pressure and again, a wrong flow. Here are some suggestions to minimize this effect. If the GC has electronic pneumatic control, EPC, the best way is to enter the actual column diameter into the software. This actual measured value for the diameter can be found on the performance summary sheet that comes in the box. By inputting the values, the EPC will give the proper pressure for the correct flow, compensating for any differences in diameter. If you ever trim the column, you'll want to input the new length into the software so that the EPC can compensate for that change in length. Let's show you how you do that. We just go into Instrument Configuration. We go ahead and click on the Configuration tab. It's already on the column section. And then we go to click on Calibrate. And now we have Set Length or Adjust Length. I like to use the Adjust Length because I just trimmed the column. I go ahead and go in there and I figure out how much did I cut off, and I know that this is a meter and that's a half a meter, and I probably cut off, 2/10 of a meter, and that's good enough. I mean, it's close enough. It'll give us a good estimation. So I put in 0.2, I hit OK, and my new length now is calculated on the column. And that'll go all the way up to the top. In fact, it'll even affect the pressure that I'm using to drive that flow so that I got the same flow rate as I used to have. But as you know, Herb, the best way to verify that you have the right flow rate, whether you have an EPC or not, is to inject something of known retention at a given temperature and make sure it comes out at the right retention time. Usually an early eluting peak is the best choice. The old school method is still the most reliable.
Okay, so we've seen that something as simple as a change in your carrier gas velocity can shift retention times. You could also have a leak in your injector or a blockage in your gas line. The blockage is the most common for split analysis. You may want to have a service engineer check the functionality of your electronic pressure control module. If you have one of these issues, you'll usually see a change in peak size as well as a shift in retention time. Let's go through the process to check for leaks and blockage. I'm going to walk you through a simple inlet leak check. It can help you catch a leak from a loose fitting or bad seal, things that happen when you install a column or replace a liner, or after the first few temperature cycles of the oven. There are 3 things I like about this test. It doesn't take much time. Also, it uses the GC flow sensor to measure the leaks, and you get feedback when you find and fix the leak. Here's a sketch of the leaks it should help you find. It finds leaks at the inlet column fitting, the gold seal, the split vent trap housing and the vent line, the septum, and the septum nut. First, we need to check that the column dimensions are entered accurately into the GC. Next, set the inlet to splitless mode. Set the purge flow to 50 mils a minute. Next, set your column flow to 7 mils a minute. Set the septum purge flow to 3 mils a minute, then allow the inlet pressure to stabilize. The total flow should be approximately 60 mils a minute. You may have to adjust the inlet pressure to achieve your set points of the column flow. Press the prep run to shut off the purge valve. This is the split vent flow. And then change the inlet configuration. You may have to press it twice if your GC is not ready. We'll monitor the total flow from the GC display while tightening fittings. If the total flow is much greater than 10 mils a minute, there's a leak or your column settings are not accurate. Okay, we have a leak. Tighten the fittings and watch the total flow reading. Over-tightening the fittings could also be a problem, so use caution. I'm going to start from the top of the inlet and work down. First, the septum nut. Next, the closure to the liner, that yellow little lever that we did. That's not it. Now I'll try the column nut. Okay, there we are. You see how the total flow has dropped to less than 10 mils a minute? This is probably good enough for our example. Oh, one more thing. What we did was the manual way to run the test. If you're lucky enough to be using LabAdvisor, you could select the appropriate GC and run the prep run leak check. If you see a problem, you'll want to replace the line.
Now, of course, there could be other reasons for retention shifts. There could be a large change in your sample concentration, or splitless injection purge time has changed. Sometimes, if you have a large change in your sample injection concentration, it will manifest also as a retention time shift. The column becomes overloaded, and so the solute cascades forward, giving an earlier retention time than expected. Just check your inlet flows, injection settings, syringe size. Just make sure nothing has changed, which would cause an increase in sample injected. If it was working before, it should work again, if nothing's changed. But if you now have a higher concentration in the sample than you dealt with before, you may need to dilute the sample to get it into your working concentration range. It is also possible that your solvent may have something to do with the retention time shift. You'll typically see this with a splitless injection because of the reverse solvent effect. We've already talked about this in another section, so I won't repeat it here. Look for part 4 on tailing peaks to hear more about it. If your splitless injection purge time has changed for some reason, you could see a shift in retention as well. Check to see that all the settings are correct, and if needed, change them. Lastly, the obvious reason for retention time shifts would be a change in temperature. This can be tricky since in a temperature program run, which is what most analysts are doing, any change in flow is also a change in temperature. If you're going faster or slower with the flow and changing temperature at the same time, then the compounds you're chromatographing are going to be experiencing different temperatures. This will definitely affect retention time and could even switch retention order. And nobody wants that. If that happens, we won't know what's coming out when. Make sure you check all the flow and temperature settings against your method documentation to make sure you don't have any errant settings. Starting temperatures, hold times, ramp rates, as well as flow rates can prove to be critical, especially if you have closely eluding peaks or a complex mixture for a sample. Again, injecting a standard or component of known retention is the best way to verify you have the correct flow, if all the other settings are correct.
Okay, that about covers it for retention time shifts. To recap, 1. For new column installations, check the exact dimensions of the new column versus the old column, and be sure to enter the right dimensions into your instrument control software. Do a leak test, then check for blockages. Double check the concentration of the sample you prepared and correct if needed. Also, check for solvent compatibility. Check your purge time and make sure it hasn't changed. And finally, check all of your flows and temperature settings against your documentation. We're making our way through all these common GC troubleshooting issues that we see. Next, let's look at changes in peak size and loss of sensitivity.
Lots to discuss there too.
Okay, let's get to it.